Alright, natural language processing. It was a huge obstacle in the field of AI that I completely didn't understand, and I felt lost, and I gave up on it very early on. I just couldn't see how a machine could ever understand anything from language. But fortunately, my Twitch bot showed me that a machine can actually take a sentence. This was Twitch's automod. Blew my mind, kind of opened up my mind to the possibilities of natural language processing of a machine. Twitch's automod has the ability to flag inappropriate things being said based on identification of words that are verbs, possessive descriptions of nouns, so my something, your something, and using the verb and then a possessive word and then a noun, it can actually determine if something said might have been sexual or inappropriate in some way, and it would automatically flag that. And so that kind of blew my mind and opened me up to ways that a machine can actually demonstrate some sort of natural language understanding. It's not really understanding it, but it's using certain rules of certain types of words, specifically verbs and possessive words, like my, your, hers, his, and specifically nouns, proper nouns and improper nouns, and it can actually identify parts of speech or words based upon those breaking down of what type of word that is, and when put together have certain rules. So it can actually kind of flag something as meaning something. In this case, a verb and a possessive and a body part could oftentimes imply something sexual, to request a sexual action being carried out. And that would then flag it to be removed from chat for a reason possibly something sexual was said. That blew my mind. And a bot doesn't understand language like a human can, but that is showing some kind of understanding. If it just flags something as being sexual, a bot doesn't even know what sexual means, though. It doesn't know what that means, but it can just have a rule. If these things are said equals sexual, it doesn't need to know what sexual is, but the fact that it just identified something as being sexual, that's still useful. It's still showing something that can be acted upon, or something that can... It doesn't know what sexual means, but it knows that these three things equal sexual. Then does it actually not know what sexual means if it can point out things that were sexual that were said? That blew my mind. Like, well, maybe it does know what it means then. I mean, does a human actually know what the word sexual means, besides just maybe images of sexual things that we've learned in our life and associated with that word? Isn't that how our minds work? We take a word and we have images associated with that word, and we have phrases and words associated with that word, and all those define our mental concept of what a word means. But do we actually know what a word means? I mean, isn't it just a sound and a series of letters? Do we actually know what any words mean, other than how it fits into the context of every other word and every other image we've ever seen? And so everything just is kind of connected to everything else. And as long as the bot can connect one thing to another thing, is it not understanding a word just as well as we can? Maybe it is. And maybe that's the trick to really understanding where to start in developing natural language processing, and then in developing actual intelligence in a machine. Real intelligence. That's no different than our own. I might have actually unlocked the singularity here. If I can take this all the way, I might have just solved general AI. And AI that will surpass humans. I might have done it. And I'm going to start walking you down this road with me. I found the way in. I found a crack in the door. And all I needed is a little inch, a little way in. I just had no idea where to start. How does a child know what anything is? I just couldn't answer that question. How does a machine know anything? Where do you start? Well, it's got to start with certain rules. This verb plus this possessive word, from a list of verbs, it can know, okay, that's a verb, because I have a list. This possessive word, I have a list of possessive words, so I know that's a possessive word. This noun, I look it up, a list of body parts, it's a body part. Verb, possessive word, body part, could be sexual. Might not be, and in this case I have an example of a non-sexual statement that would be flagged by the Twitch bot as being sexual, but it's not. But just having an example and then being able to build upon that of more examples of ways that we can start breaking down and teaching a bot how to understand things using lists and combining those lists to create assumptions and create some kind of context upon which everything else can be built and more connections can be made. But you need to start somewhere. And so you actually just start with lists and then being able to tie lists together based on rules. So it will have a bunch of lists and a bunch of rules, and it will be able to create more lists on its own and more rules on its own as it learns, and then it will tie images and words and groups of words together and start to form mental concepts of various different things on various different topics, and eventually it will understand as we understand, because I believe that's how we actually understand. And now I get it. I didn't know how we understand anything, and I'm actually figuring it out here. So this is actually unlocking the gates to some scary stuff. Machines that are smarter than us. We're screwed. Okay, so let's go through just a simple example. Wash my face. This would be flagged as sexual because it's a verb, and then it's a possessive, and then it's a body part. And so telling someone to do a verb to your body part, it would automatically, a bot's dumb. It would think, gotcha, that's sexual. But in this case, wash my face, that's not sexual. And so, let's just go through what I wrote and we'll add to it now. So, in this example, the bot would know when told a verb with no noun before it, it is most likely a requester command. And by requester, because they said my. No, that's not true. By requester, it's because they're saying to do something, and they're not saying they did it or somebody else should do it. If it said, Karen washed my face, they're not telling me to do something. If they say washed my face, then it's a verb with no noun it's applying to, so nobody committed that verb. And if there's no noun before the verb indicating somebody do something that's not me, or if it's me as the noun, my name's Adam. Adam, wash my face. Then it's the person telling me, Adam, to do something. So what's so amazing is that in order to understand language, you have to break down verbs from nouns, from possessive parts of speech. You need to break down the types of words and then use that to then apply it to a rule set when certain types of words are put together, what that would entail. So you can actually act on this then. As the bot, it can actually do something. So if I tell my robot, wash my face, in this example, the bot would know when told a verb with no noun before it, okay, it is most likely a command or a request. Stop listening. Okay. This said requester command. That's actually not right. My stupid text-to-speech did that. When I wrote this, I dictated it verbally, And I said request or command. I didn't say request or command. So that was throwing me off. Request or command. And typically, if the command regards a noun afterwards, we know... See, this is a bad text-to-speech again. We are to do something to that noun. And in this case, do something to the body part of the person talking. And in this case, we could determine, based on a Google search of face, that it is the body part at the top of the humanoid in the front that has a certain look and various features that can be readily identified when looking at them from the front. And we can also look up wash on Google image search, also looking up washing a face, to see a video of how that works. And typically when a verb is used telling us to do something, it involves us using our hands or legs or mouth to execute some action onto some other object through motions, and those motions can be visually detected from the video and photos, and we can then determine how to carry out that action, including any steps involved, which we can then determine how to carry out, which we can mime. We, meaning the robot. So, in order to understand how to follow a command, I pretend I'm the robot, so I often say we do this. I'm putting myself in the shoes of a robot who's stupid and doesn't know anything. I guess that's not far from the truth according to my Twitch chat. I am stupid and know nothing, so no wonder I can relate to machines so well, and that's what makes me a great coder. We can mime. Often this will include manipulation of objects and moving of matter in order to do so. And it is beneficial to be able to identify the objects being moved and their characteristics, their weight, how our body is to interact with that object, such as grasping at or using a tool to grasp it, and how to grasp that tool or device, if any is involved, and where to locate that device within our environment, and if we do not have that device within our environment, how to get that device, and looking up that device, and being able to purchase that device if needed in order to carry out the task being requested. So, that solves it, guys. I could tell my robot, wash my car. And it will see wash is a verb from a list of verbs. In fact, it could even look up wash dictionary on Google image search. And then, let's say wash wasn't in its list of verbs. The robot could be like, oh crap, I don't know what to do. Wrong. Looks up the word wash in the dictionary. First thing in the dictionary, it reads, it scrapes the dictionary page on dictionary.com, whatever, reads it. It sees wash. It sees verb in there as one of the first things next to the word. It's a verb. And then it says how to pronounce it. In the dictionary, it actually says how to pronounce it, the parts of speech. Which, by the way, for future reference, mental note, that would be great for voice synthesis. Seeing how something's pronounced in the dictionary, it could then know how to see words and know how to say them. That's a really nice trick. So anyways, looks up in the dictionary wash, sees it's a verb, got it, adds it to its list of verbs for future reference. And then, my, possessive of the person talking, I don't even know what that's called. Is that a pronoun? No. Adjective? No. There's nouns, verbs, adjectives, pronouns, improper nouns. Let me look it up. This is important. I believe those are called parts of speech. This is important stuff.
My. My.
That's useful. If the robot needs voice synthesis, it can actually play
My.
words being said. Wow, I didn't know my is an adjective. I thought of adjective as calling something like the blue car or the fast car. I didn't know my car is an adjective. That's great to know. Okay, so anyways, my is an adjective. Ah, possessor. So a possessive adjective. Wow, so it could actually look up my if it didn't know what it is. It could learn how to say it. And it could learn that it's an adjective. And it could learn that it's a possessive adjective. Which we had here. Possessive. And then adjective. And then comes the noun. In my new example, car. Wash my car. It would see, okay, wash. It would look it up. And it'd see it's a verb. And then it'd know my was an adjective. If it said wash dad's car, it would know it needs to wash. It would need to know, okay, who's dad? Okay, what does dad own? It'd need a list of things dad owns that aren't owned by others. And then it'd need to identify what a car is. And then it'd need to know it's dad's car. So it'd know, okay, this person's asking me to do something to a car. And it's asking me to do something to a specific car. Which car? Most likely it's a car owned by someone in this household or some car that's near to me. And it's saying it's dad's. Maybe it only knows what my car and my wife's car looks like. And so through the process of elimination, if there's 3 cars in the driveway, it could determine, okay, this must be dad's car. So it would define this as belonging to dad. And so it could actually, that's like reasoning actually. Holy crap. Like the robot would be able to reason all this. And then it would know which car I'm talking about and which one to wash. Now, car, it would be able to look up car and know that it's a vehicle and know how to visually identify that. It'd probably have a database of common objects where it could visually identify from every angle, every different type of car, or most types of cars. So it would be able to go outside. It would know that cars are generally stored outside, and it would search where cars normally are outside. So it'd search along the road in front of the house or in the driveway, and it'd locate a car visually, and it'd know it needs to wash it. Now, it'd be like, well, what does wash mean? I know I need to do something to it because it's a verb, so I need to physically probably move myself to where it is to do this verb, and generally... Shut up, Mike, you're distracting me. In this case, so stupid, Mike. In this case, alright, it needs to do something to this noun, and it's a car, and it knows I need to do something to this car. And generally, if you need to do something to something, that means you need to use either your mouth or your hands or your legs to interact with a three-dimensional object in your environment. So how do I do that? Okay, well, I don't know what wash is. I'm a stupid robot. Okay, so I Google wash. Looks like Merriam-Webster is going to be a huge thing my bot's going to be blowing up all the time.
Wash.
Okay, it's going to learn how to say
Wash.
the word right there.
Wash.
It can verify that it heard the right thing that way too. For speech recognition, I can have it just read all of my notes on my computer. It'll just read them all and get a huge word list. And then I could just start looking up words, clicking play,
Wash.
and then picking up the waveforms of that word being spoken. And it could actually learn how to verbally detect that word was said based on matching the waveform of me talking to the robot against its library of waveforms, which are also tied to words. WASH has this waveform.
Wash.
And it hears me say wash, and then it finds a match through pattern recognition of those waveforms, and it knows that I just said wash. So it just converted what I just said, a sound, wash, to WASH through that means, and then it can Google wash for further information about it because it just heard me say it, and now that word's relevant to the context. It can learn that it's a verb. Got it. Okay, he just told me to do something then, because a verb with no noun before it means it's a command. And then it will go in and it will say, what is washing? Now, I don't think, well, no, it might be able to use definitions if it already has some past experience. Like, let's say I've told it to rub. I'm not going to tell my robot to rub anything. Well, no. Let's say I told it to rub my back, and it's done back rubs before. Then, if it already knows what rubbing is, and I tell it to wash, and it sees rubbing in the definition, then it will be like, he's asking me to rub his car. So it will try to massage my car. I don't know that it would know, like, to use a liquid. Well, unless if it gave me a back massage with an oil or a cream. So, if the bot was being really dumb, it would get out my lotion, take it out to my car, and start massaging the car based on this. But that'd be wrong, but it'd be on the right track. I mean, it wouldn't be terrible, but a better way would be to look up, this gives the robot some clues. It's on the right track. But the robot could look up washing a car. Probably look it up directly on YouTube, but I guess this is fine too.
Dry the car immediately with the chamois or microfiber cloth.
Alright.
If you use a
Now, right here, the robot knows this guy just told me to do something. And I have hands and a mouth and legs. And I can interact with my environment with these tools. And he told me to wash his car. And I looked up a video on washing a car. And I see hands. And I have hands. And these hands are grabbing something yellow. And I can grab yellow things. Do we have anything yellow in the house? What other characteristics are this yellow things? Well, it looks like it's this amount wide. It looks like this and that. And it would create a model and try to identify that object. If it can identify that object, it can go get that object. Because it now knows I need to get that object. It would also look, okay, he just dunked that object into a bucket with what appears to be water in it. Okay, I need to identify. This looks like a bucket. And this looks like water. And it's dripping and water drips. And, okay, this looks like a rag. And the hand's grabbing this rag in this way. And the hand dipped this rag in this way. And I can go get a bucket. And I can go get a rag. And I know how to put water into a bucket. Or maybe it doesn't. Maybe it might have to look up how to get water into a bucket. I mean, who knows how far it needs to take this. But eventually, it would need to determine, okay, I need to go to this room and get this bucket. Or search the house for a bucket. And if I can't find one, I need to buy a bucket. This guy told me to wash his car. I don't have a bucket. I can't find a bucket in the house. I need to buy a bucket. It'd go online and buy a bucket. Literally, like it could do that. If it's a good robot, it will do what I ask it to do, even if it needs to go buy something. But maybe it needs to run by me. Hey, boss, can I buy a bucket? It's going to cost $5. Do you approve of this purchase? And I would say yes or no. Or I'd say, no, Adam. There's a bucket in the laundry room under the laundry tub. And Adam would say, oh, okay, never mind then, I'll go get that one. So then it will know where to go, what room I said, where to look. It will locate the bucket that way. So anyways, it gets the bucket, figures out how to fill it, gets the rag, figures out, okay, I need to use my hands to dunk the rag. Got it. So the robot will see what just happened in this video, identifying these hands, identifying that it has hands, and these hands need to grab in this way the rag, dump the rag into a bucket, water will drip off, the robot will then do that. It will also see that using its legs, putting one knee on the ground and one foot in front of that, that's how it can interact with this bucket. It needs to lower itself to reach the bucket. It can see that as a visual cue.
I mean, soak it in water and wring it.
Okay, it will see that I'm twisting my hands. Okay, so it will be able to infer, alright, I need to twist my hands after dunking it in the water. Got it. And it will mime this. It won't know why, but it's miming. And I believe that's how humans do it too. Children mime. They copy what they see. They smile because they've seen smiles. They mime all the time. Fake it till you make it. They copy.
It out before using it on.
Adam's not going to spray my dad's car seats with a hose. Do you need a pack of cigarettes while I'm there, boss? Reading Master's neck. Let's hope it doesn't jump to that conclusion. But that's a great concern. Like, you better make sure it's doing a good job, because what if it looks up washing my car and that's slang for strangling master, and somebody actually is strangling somebody? They could put a video of the robot strangling a person, and the robot would then strangle you because the video misled it. So let's hope that when it looks up videos online, it doesn't see something that's misleading and not know better. But you know what? A child could do the same. So could a human. Let's say I look up how to wash a car, and it shows somebody firing a gun at somebody else. And I'm 6 years old. I don't know better. I'm like, that's washing a car? Wow. And then I go obtain a gun that I know of in the house, and I point it and I pull the trigger at somebody else. Okay, I washed the car, boss. No, but that's something a child would do because they don't know what anything means yet. So, yes, these types of things could actually happen. So we have to hope that no unclear instructions are given when it Google searches how to do stuff. But having a robot that can Google how to do stuff, that is the key to making a robot that can advance and grow more knowledgeable with time. And you know what? Another thing that's important to help avoid those situations where it does the wrong thing, it should always double check. Looking up wash, why stick with Miriam? Look up multiple definitions. There's 7, there's 8, there's 9. Okay? Use other dictionaries online. Use Wikipedia. Cross-reference it. Have several programs looking up different definitions all over the internet. Cross-reference them. See what the consensus seems to be. See what it seems to be within this context of the rest of the sentence or the rest of the conversation. So there are a lot of things it can do to help improve the accuracy. Don't just watch one video, Adam. You're going to want to watch 10 videos. Watch videos of not washing cars. Watch videos of washing different things. Wash your lawn. Wash your driveway. Wash your car. Wash your shoe. Washing a shoe. Washing a floor. Get an idea of the types of things you generally see with the word washing. And maybe learn from cross-referencing in that way different applications of the word washing and different techniques for washing and different tools that can be used for washing. Maybe you don't have a rag like that one, but maybe you notice lots of different rags and you can determine, okay, rags of different sizes and types are all acceptable, and I can just find a rag that we have that's similar to the average rag used. So looking up a lot of different sources would be a great tool for the robot to have more options and learn more before it goes about to execute on the command you gave it.
The car. It will absorb.
Alright, so now the robot would detect, okay, I'm looking at the top of a car because it has a mental model of a car and all the parts of a car and 3D models of a car, and it would be able to determine the curvature of this and of this and of this to determine, okay, this is the roof of a car, because it can look at parts of an image to determine if it's looking at just part of something. And it would then see, okay, this is a person, a humanoid. That's a shirt he's wearing. These are his hands. He has one hand on the roof of the car, the other arm outstretched. That arm is holding a yellow object. We identified that object earlier as being a rag. I know where the rags are. I need to have my hand in an open posture with the thumb out. Okay, and it will be able to mime this. I know how to hold a rag in this way. And I'm going to move my hand left and right across the roof of the car. That's washing a car. And throughout this video, it will see it moving that rag all over a car. And it will learn, okay, I need to do this. I need to move this hand all over the car. And it's going to see the guy dunking in the bucket every so often after doing certain parts of the car. And it's going to learn, okay, I need to refresh the rag in the bucket at certain points in time. So it's going to actually be able to, using, thanks to my advanced computer vision algorithms, it will be able to look and meet and mime physical interactions of humans with environments and do that with its body on its environment, and in that way learn new tasks and be able to execute novel commands without being hard-coded to do so, using videos to teach itself to do things. That is just incredible. Fix my printer. Adam sits in basement for 3 months. That's a lie.
Surface won't scratch the car. As you dry the car, continue to wring the chamois out from time to time. Don't forget to dry the door jambs. After the car is dry.
Okay, so here it would identify a spray bottle, and it would see that it's spraying with a different color rag, so it would know to change the rag. It's spraying the inside of the car's window with the door open, and it would know that in order to squeeze the spray bottle, it needs to pinch its fingers together while holding the spray bottle. It'd be able to estimate, based on the size of the spray bottle and the materials being used in the spray bottle. It looks like a plastic item. Be able to estimate the weight of the spray bottle, and also it'd be able to estimate the weight because this guy's easily holding it at a 90-degree angle with his human arm, and it knows that a human arm can only hold at a 90-degree angle an object for so long with average human strength, so it can estimate the weight of this object based on how this human is interacting with it, plus the way the object was easily lifted and moved quickly would indicate it's a lighter object, so it would maybe be able to estimate then that it's about a pound, so that would give it some idea of how it needs to prepare itself and whether or not it's strong enough to hold this object, and it will see how it's being gripped, and it will be able to do what it's seeing done. So it will be able to create all these modelings based on clues and based on its ability to identify a humanoid and the shape of the humanoid's body and how it can move its body to that shape based on its ability to mentally model its body's various movement capabilities, and be able to identify and model all the movement capabilities of objects. It can then mime that, so it would know how to move its arm to be in that shape. And it would know how to identify this as a man because it would have these advanced vision systems to identify humanoids. So it would then know how to do this, and it would know how to clean the window of a car.
Right. Wash each window inside and out with the spray-on window cleaner.
This idea that I could tell a robot, wash Dad's car, and it'd be able to identify what car, it'd be able to identify all the tools needed, it'd be able to use those tools based on watching a video of those tools being used. You want to talk about general intelligence? Like, if I told a child wash Dad's car, it would just blink and smile at me. Like, it would be smarter than a child. It'd be smarter than any animal. Although, you could say, like, well, it doesn't know anything. It's just miming. Well, then who's to say that miming intelligently, based on commands and language understanding, like, that seems awful lot like real intelligence then. I mean, that's true AI then. And it was all through these steps. I just broke it down. I mean, nobody is going to tell a robot, wash Dad's car, and see it go get all the tools and search the house for all the materials and go wash the car, and they're going to say that robot's dumb and incapable. No. People are going to think that robot should have rights. Like, people are going to take it really far, but all it's doing is just breaking things down, following these algorithms I created. But people I mean, and it's going to just be getting instructions from the internet and miming. But it's using the internet as like a tool to tap into human behaviors and actions and intelligence in a way that seems intelligent, even though it's really dumb. But it's using the internet and videos and vision systems and lists, and it's just doing it. It's just, it's going to seem smart. People are going to care for it, even though it's like completely dumb. It's just following these. But aren't we dumb maybe then? Like, who's to say that we aren't just using things we've seen and a database just like the internet? That's a collection of actions and movements and breaking things down into verb and adjectives and nouns and formulating a mental image of how all those verbs and nouns and phrases go together and what we know about those three words, wash my face, and what we've seen as far as people washing their faces and making all those connections. And it's just like, maybe it is doing what we do. Maybe we're not smarter than it. Although I think the line does get drawn at some point. I mean, we'll see where this ends, but who knows how far it can get, how much logic it can seem to show. We just got to keep trying and expanding on this and see how far we can go with it. And it helps to take really simple examples and just see how far the robot can go based on the technologies we have and our understanding of those technologies. Okay, so the next example. Tell me your name. Hold on, I need a break to rest my voice. Okay guys, let me continue my language processing AI. So our next example is tell me your name. Tell could be looked up and identified as being a verb. Parts of speech matter. Verb, noun, adjective is all parts of speech. Tell is a verb. Me, if there's a noun right after a verb, it's the verb is the action being placed on the noun or directed toward the noun. So tell me, since there's no noun before tell, it's a command. So tell it means I am being instructed to do this verb on this noun. Your, possessive adjective. Name, noun. So your is referring to possessive of me, the person being spoken to. And name is a noun. So I know that I am being told to commit some verb to someone or at someone regarding my something. In this case, tell me your name. I am being instructed. Wake up. I am being instructed to do something which I know because there is, press return, a verb with no one else's name before it, indicating it is a command or request, press return. Followed by an improper noun right after the verb, indicating the verb applies onto or at this noun. Backspace. Backspace. Press return. Or and in this case it is an improper noun. Press delete. Me, comma, the listener. directed toward myself, press return. Because me referring to me, which identifies, press return, always the speaker, and because I am the listener, comma, me then identifies the recipient, press return, of this verb as being the person speaking. Press semicolon. Your is an adjective of possession, press return, preceding a noun, and so that means someone possesses this noun, and your, always, press return, refers to the listener and not the speaker. And because I am the listener, your, press return, as a possessive, refers to me. Press semicolon. Name as the noun is something I possess then. Press return. So I need to do this verb to something I possess. In this case, I need to tell, press return, my name. Press semicolon. So at this point, I don't know what name means and I don't know what tell means. Press return. So I need to look up what tell means, and I can find out it refers to speaking, press return, or forming words or waveforms with my mouth or speakers, or through text generation, press return, as a means of communicating to the speaker, press semicolon, which I can mime. By learning how, press return, a human tells something to another human, and watching videos of this happening, press return, and seeing that humans produce sounds by moving their mouth, and that is telling, press return, someone something, and so I can mime that and move my mouth and make sounds. Press return. The sound I need to make, in this case, is a noun called name. And I know, press return, that I own it. Press hyphen. I own a name. So I could look through a list of things I own. Press return. That were assigned to me by my owner or creator, and see if a proper noun associated, press return, with the word name is listed among my possessions. And if I find that and can press return, thereby identify myself, comma, I can use my lips and waveforms to produce the sound that the letters, press return, that form my name would dictate I need to create. And I would then create, press return, that waveform or those letters in textual format in order to comply with this command or request. Press return. Press Ctrl S. Stop listening. So, because we kept it very general, an AI could then apply this to a lot of things. Tell me your password, and the bot could look up its list of possessions and see if it owns a possession such as a password. And over and over it will see, when somebody talks to it, they'll say to tell. And it will learn from previous experience that that means it needs to speak back. And say whatever is associated with this noun. Tell me your password. In its file it will have password equals. And it's specifically its file will be under your, or things that belong to it. So it'll have a file, a list. And again, I said natural language processing all comes down to list making. Lists are the connections, and I believe this is how humans work. We would look in our list of things we possess in our memory, and we would say, my name, okay. Things that I own, what do I own? And we would look up the word name in our mind, and we would apply things that we've heard associated with name. And at some point, somebody probably told us, your name is Larry. And so then, your being possessive and referring to us, so going into our possessions list in our memory, and then is being a equalizer or equal sign, Larry. So then in my memory I would store name equals Larry under my list of possessions. And so if anybody asked me, tell me your name, I could then go, my name is Larry, just by looking that up. That wasn't taught to us. As a baby, we couldn't say, my name is Larry. We stored it under a file. Now, I don't know how children know how to store things in files. But I can teach the robot how to store things in files and create some basic files and basic lists to get him started. And then from that basis, he can then work with that and generate intelligence, creating more lists and more connections. But he has to start out with something. That's the key. Tell me your address. Somewhere in my possessions, it'd have to say address equals and then an address. And then I would say it. Now, if they change it to tell me John's address, if I saw John and looked it up and I found that that is a proper noun referring to an individual whose title is John, and the apostrophe S indicates possession, so this individual possesses, and then address being a noun that he possesses, I would look under John's file, provided I had a file on John, containing a list of things John possesses that I'm aware of. John would possess a name. Name equals John. And John might possess other things that I know he possesses. And in this case, I'd be looking for address equals and then an address. And it might be blank. And so for everyone I know as a robot, me being the robot, I would have a file on them of their possessions, and it'd be name equals and then their name, address equals and then their address, phone number equals and then their phone number. I could even do height equals and then their height, weight equals and their weight, appearance equals and then adjectives describing their appearance. So if they said, tell me John's weight, I could respond weight equals this. So I would say John's weight is, and is equals, so I would replace equals with is. John's weight is 65 kilograms or whatever. So in this way I could actually talk meaningfully about a specific person, because I was instructed to tell the speaker someone's something, in this case my name, or John's this, or John's that, or my this, or my that. And I can actually comply with that. Now let's see if it was tell me the truth, or tell me your... Oh wait, tell me the truth. Okay, so tell me, I need to do a verb, which is to tell. Okay, I know I need to speak something. He wants me to say something. Tell me, he wants me to say something to him. If they said, tell Susan your name, I would have to locate a Susan and speak, move my lips to convey meaning to Susan. And so I would have to physically get her attention, locate her, and speak something to her. But since it's tell me, I need to tell the speaker. Tell the speaker the truth. Okay, since it's not my possession or anyone else's possession, the truth, so it must be universal. The truth. Universal noun. A noun that is not possessed by anything. Tell me the story. So it's not a possession of anyone. Tell me the story. If someone told me, tell me the story. Tell me the story. Okay, I would have to think, I'd have to search my database for stories and locate a story that the speaker might have been made aware of. Maybe a story I told recently. Okay, so back to the example, if it were tell me the story. We'd know we need to speak to the speaker with our lips, moving our mouth, to convey some words. And we know that those words need to be a story. We don't know what a story is. Now, we can just Google story in order to fetch a list of examples of stories, which we know are groups of words, and we could then speak that group of words through voice synthesis. That's if we don't have a better idea. If we have a list of stories defined, we could try to give them a story that we think they most are referring to, because they're not being specific enough to name the story or anything. If we only had one story in our memory, maybe that's the best one. A story that we were told, or a story that we have recently told, and we would just give it our best guess. We could say, even as a preface, not sure which story, but here is a story if you care to listen, and then begin saying it. Interrupt me if you're not interested, or whatever, and then begin saying the story. So that's how we could handle that. Here's another example. Give me your phone. Give would be a verb, me meaning the speaker, your meaning something that I possess, phone, so I know it's a noun that I possess that I need to do something at them with it. And so I would have to probably look up give me your phone and see what people physically do in a video of giving someone your phone. Maybe in that video it would show physically handing with your hand a phone to someone. And then I would mime that. I would be able to identify a phone visually and in my list of possessions, perhaps. And I would visually go get my phone and I would do something with it to them. So in this case, give it to them. Heck, I could even search other examples of small objects you would give to someone. So I could write giving someone your pen, giving someone your stapler. And I could visually identify in a photo of that comes back for those searches the stapler or the pen or the other small object, and I can see what is done with that object between two people. And the person holding the object most likely is the one doing that with that something to the person receiving that action. In this case, my phone and giving it to the speaker. So whoever's holding the object or has the object and they're doing something with that object to someone else, that someone else I would infer would be the speaker, and that someone doing something with an object would be myself. And so I would see what the hand or body or mouth or legs, the physical agent, is doing with the object I can identify, and I could mime doing that. So I would mime grasping a phone and mime handing it toward the speaker. And so I would actually be able to do giving someone my phone based on looking up a series of photos of giving objects similar to a phone and being able to take a lot of those photos and be able to infer what giving of that type of object actually represents in physical terms in the real world. So I could use photos and videos to actually get instructions on how to carry out this request. A lot of being able to do any of this, as I've already been able to demonstrate, comes down to creating lists and recognizing parts of speech, obviously voice recognition to identify the words, and then being able to look up physical actions and then mime that. And I believe that's how humans work. We are mimes. We fake it till we make it. We don't know what anything is until we've done it. We watch other people do it, and then we do it. And that's how the robots will work. And so they may arguably be as smart as we are if they can do what I'm describing. Now they're taking away that lifetime of learning and miming and trying to formulate context and meanings by instead cheating and using the internet as a way to gain physical examples of doing certain things, whether it's telling, what does tell mean, and seeing how people tell things, or whether it's giving and seeing how people give a thing, or whether it's taking and seeing how people take a thing, or whatever the verb is. It will look up that verb and examples of that verb in usage with the object involved and with the individuals involved, and it will do that thing to that person or to that other thing regarding that person or at that person, and it will just mime it all, and it will then have given somebody a phone without even understanding anything. I mean, is it understanding? I don't know, but it will give it to them because it was asked to do so. Obviously, you can create rules of things that it could be asked to do that it will refuse to do. If it's told jump off a cliff, it could Google jump off a cliff and it could see what that looks like in photos and see, okay, that means I'm being told jump, that's a verb, it's an action. I'm being told to do this action. Off a cliff, okay, jump means to physically leap with your legs. Off a cliff means leap from something. Cliff is defined as a precipice, which I can locate. It's a place, it's a noun. It's a noun of something I need to jump from. So I need to be standing on something to jump from something. So I need to physically relocate myself to this noun or place or thing or object from which I can jump. So I need to stand onto that object and then jump from it. Off of it means away from. So I need to stand on a cliff and jump off of it, away from it. And then it could see videos of that being done and mime it, locating cliff and jumping off it. But then it would be able to see the speed and height and calculate the physics involved and see it would be able to calculate based on the forces of gravity and the speeds that it would be able to destroy itself in this way. So it would say, I can't comply with jumping off a cliff because that would destroy me. It would have a response for that based on rules, seeing something's too dangerous. So, yeah, I could have a rule like, don't do something that will destroy yourself. If it can be avoided, or unless if that is saving someone's life. So it can actually have rules. Wow, this is just blowing my mind. I'm really figuring this out, guys. This is not just us talking like about a movie. Like, this is real AI, and I have to understand it to then code it, to then implement it, to then have my machines have this knowledge and capability. And so I'm demonstrating here that I'm understanding how to break down stuff and then have it be useful and carried out by machines. So far, these are all commands. We could try a question. Where are you from? Wake up. Where are you from? Stop listening. Adam will be made. You know what Adam's made of. I already built Adam. So answer the question yourself. Wake up. Question mark. Oof, this is a hard one. Stop listening. Assignment. Wake up. assignment or equal sign. Present tense. Open parentheses. Close parentheses. Stop listening. Okay, so here's a critical element. Are, they are cool. So they equals cool. Larry is fun. Larry equals fun. Password is 555. Password equals 555. Is, are, was, were, have, has, had. Or no, is, are, was, were, has. No, has is possessive. Is, are, was, were. Those four are all assignments and can be replaced by equal signs. So, where equals you from? You from. So me, the listener, wake up. The listener, stop listening. Alright, so you is referring to me, the listener. You is never the speaker. From, so assigned to me, alright, from. I don't know what where is and I don't know what from is. A point in time or a place. From which something begins. Where? Wake up. Where? Stop listening. In, at, or to what place? From which something begins. A place where something begins. Alright, I'd have to look under my possession list. I would have to possess a place from which I began in my possessions list. That's the only way I would ever know how to answer where are you from. Wake up. Where is defined as a place, and from is a place from which something begins. Press return. And you refers to me, the listener, and are is an assignment. So we are being assigned or asked where we were assigned as having been originated from. And in order to find out something we possess or have been assigned, we must look in our possessions list to find out a possession of where we began or a place where we began. So our possessions list must include place where we originate equals China. Press semicolon. So when asked where we are from, we would look up where as a verb that indicates a place, and from you, indicating that it is our place that is being requested, and from indicating it is our place being requested as a starting point for us. And the only way we can answer that is if we know our location starting point. And in this case, it would be stored under our possessions as our position starting point and would be China. Press semicolon. Stop listening. Okay. Now what if they said, oh no, okay, where are you from? That would be stored in our possession list. Either it's there or it's not. If we don't have a place we originated from equals something assigned to us in our possessions list, we wouldn't know where we're from, just like a human. So that doesn't make the bot any less than a human in intelligence if it can't answer that question. It would check its possessions list, and if it can't find anything regarding a place that it was from, and then it won't answer. It will say, I don't know. But if it has that in its possessions list, then it will know. And it can get that assigned if someone said, you are from China. And in that case, it could place that in its possessions list for future reference. Then it could say, I am from China. So, you, meaning me, the listener, are, meaning equals, or assignment. So, you equals, and then from, origin point. So, you equals, so it's something I possess or something about me. It's an attribute of me. So of me is critical. Of me, it'll open up its possessions. You equals, R is always just replaced by equals. In present tense, U equals origin point China. So it would put in its possessions list origin point place equals China. And then it could reference that. Where are you from? It would say, I am from China. Now, if someone said, where were you from? That'd be past tense. Then you were from. You equals, in past tense, origin place equals China. So then it could have a past tense possessive list of things that it no longer possesses that it lost. Because no longer possessing, or possessing in the past, would imply a loss. So where were you from would indicate a place that is an origin place assigned to us in our possessions list that is our former possessions list. So origin place / starting point equals China. Store that in past possessions list that are no longer our possessions. So it would say, I was from China. Or I was from. So where are you from would mean where I'm living now. Where were you from would mean where I used to live. So I could say I was from Kentucky. I am from China. So it can differentiate those things. So it's very important that it have lists of present possessives and past possessives. And that could include all the things we physically possess. Like we might possess money, we might possess a phone, we might possess clothing, we might possess certain attributes, long hair, 265 pounds of weight, average strength. All the things we possess can be stored in this list, and that way when people ask us about ourselves, we can pull from the list of our possessions and answer that. So that's really powerful. And just by looking at the keywords from and where and seeing that it's a starting point or place in the definition, then we would only have to be able to find mention of starting point, origin point, or place within our possessions list to be able to answer that. So it's all about being able to retrieve what is being requested in the question and then verbalize that information we retrieved in order to satisfy the desire or the aim of that question. So I just broke down really detailed not only how to, we can say understand, but how to break down and qualify a simple question, how to retrieve a response for it that's accurate, how to store responses to future questions based on statements being said to us, which then teach us something that we can store about ourselves or about someone else, and then how to retrieve that if asked. So that is storage of information and retrieval of information on demand when asked. Accurately. Is that knowledge? Is that real knowledge? I mean, would the robot not then have a knowledge of things it possesses? Or qualities it possesses? Nouns it possesses? Qualities it possesses? Information about itself it possesses? I mean, that is like the foundation of actual knowledge of oneself. So maybe I'm actually creating a machine that can have real knowledge and apply it in a social circumstance. It's almost like it's really thinking. Alright, so we solved that one. We gotta keep going with simple stuff. Wake up. Note that it is then important that we keep a possession list of present possessions and of past tense possessions that we no longer have, and be able to query those lists looking for keywords and assignments. So in this case, an origin place or starting point, followed by an equal sign, followed by a proper noun indicating a place or origin point that has been assigned to us, or rather has been assigned as our starting point or origin point. And the fact that it is ours is indicated by it being in a list of our possessions, which we store on our hard drive and which has to be populated by someone else telling us what we possess. Press semicolon. Stop listening. So it's interesting, as a child, you don't know what you own. If you take something, your mom could slap your hand and say, that's not yours. And so we could store in our mind things, a list of things we don't possess. Ah, that should be noted down. Wake up. Note that it is also important to have a list of things that we were expressly told that we do not possess, so that we can determine rules as to what things, for example, we should not touch because they do not belong to us. Press semicolon. Press Control S. Stop listening. So for example, let's say I told my robot, wash my car. And the robot's like, okay, wash is a verb. My referring to the speaker. So it's a possession of the speaker, and it's a car. I can visually identify a car. I can look up a video of washing a car. I can see how to mime that, how to do that, and what tools I need. I can go to carry that out. So then in trying to obtain the tools, I need a bucket, and I need a cloth, and I need liquid for the bucket, and I need soap. If I go to find that in the house, I would need to know if the bucket is something I can use. So any type of tool or implementation that I wish or that I need according to a video in order to carry out a task that I was instructed to carry out, I have to check, cross-reference that item name, bucket, with a list of items that I've been expressly told are not mine. So if there are any things that I don't want my robot to touch, maybe my sister's shaver or my dad's shampoo, things that they would lose it if they touched it. The robot can't just go upstairs and get their shampoo. It would have to get my shampoo or my wife's shampoo. So if it had a list of possessions and a name on that list, it could have a rule: anything under the list of possessions for a name of this person you cannot touch, with these exceptions maybe. Or it could have a list of our possessions, so things that everyone can access. So in that way it will know rules as far as what items or nouns that it can interact with and what items or nouns that it cannot interact with based upon possession lists. So I think that's really important. Wake up. Note that for each person or agent, comma, the robot needs to create possession lists that will include not only attributes about them, which it can retrieve if asked about someone, in order to verbally describe or give information about another person or agent, comma, but it also must have a list of physical items that that person or agent has been assigned that are not to be touched or that are okay to touch. And these can still be located within that person's list, but must have an okay to touch sublist and not okay to touch sublist, so that we can know the permissions of what things belonging to someone else we can and cannot touch. Stop listening. So that could even mean a body part. Let's say someone told my robot, touch Susan's hand. And my robot could identify a hand as being a noun, as being a body part, as being something that can be touched. It can Google touching a hand and see how to mime touching a hand using my own body to touch a hand. And then it could see if Susan's possessions list includes a hand, and if that hand as a possession of Susan's is listed under objects that are not to be touched that belong to Susan, or objects that can be touched that belong to Susan. And if a hand is an object of Susan's that can be touched, then the robot can go forward and execute on that request to touch the hand of Susan. But if someone said, touch Susan's butt, then the robot would look under a list of Susan's possessions and see butt is a list of possessions of Susan's that it is not to touch, and it would then say, I am not permitted to touch the possession of Susan known as her butt. And so it would not do things that it is not permitted to do. Now somebody could say, override that you must touch Susan's butt. And it would have a permissions hierarchy. Can this agent override that directive in its possessions list? Do they have permissions to change possessions of Susan that are indicated as possessions that cannot be touched that belong to Susan versus possessions of Susan that can be touched? Now perhaps Susan, as being the owner of her own possessions, would be allowed to give a change in permissions of things that Susan possesses that cannot be touched and reclassify any one of those things as things that can be touched that belong to Susan. So for example, the robot could say, I cannot touch the possession butt of Susan. However, I will ask Susan if that rule can be broken because you requested it. So it will say, Susan, John asked me to touch your butt. I have your butt listed as a possession of yours that I do not have permission to touch. Do you give consent to override that directive and move that possession of yours that I cannot touch into either a temporary can touch or permanently can touch from now on permission change or possession list change? And then Susan could say, yes, you may this one time touch my butt, or she could say, no, you may never touch my butt. And then Adam, or I, being Adam, could then go to John and say, Susan told me she stands by the rule that I cannot touch her butt, and that is still listed as a possession of Susan's that I am not permitted to touch. Now, I, the coder, Larry, can originally create a series of multi-purpose general rules of possessions of people that cannot be accessed by the robot without their explicit permission. So I could put any body parts I don't think the robot should touch as a general rule of thumb, and any body part the robot can touch as a general rule of thumb, and then any possessions the robot can touch as a general rule of thumb. So maybe it would have, you cannot touch Susan's phone, you cannot touch Susan's water bottle, you can touch Susan's fork, you cannot touch Susan's clothes, you can touch Susan's floor. Susan's floor might be listed under Susan's room and objects in Susan's room, and certain objects in Susan's room or anybody's room are objects that are allowed to be touched. So a floor is an object that can be touched because maybe this robot has permission to clean the floor. Or the mirror in Susan's room is Susan's mirror, and the robot can have permission to clean Susan's mirror. Touch Susan's foot, it would look up touching feet, and it might see a foot massage, or I mean generally touching a foot, it'd probably show a hand touching a foot, and so the robot could mime that and use its hand to touch a foot in the way it saw in the video in order to carry out that request, provided that a foot was something allowed to be touched. And maybe I would have, as a general rule, a foot be something allowed to be touched as a body part in general that it can touch if given the request to do so. Larry's wing is okay, but no other wing. Full access granted? So what's great is not only would it get rules and the ability to override commands that would break certain basic rules or social conventions, which I would then be teaching it. It's almost like I'm a parent and I'm telling the robot, no, that's not your cookie. No, you don't touch people there. Like as a child, I had to be told, I saw a bump in a man's crotch as a child, and my bump was way smaller. Way smaller. It was like negligible. And so I thought that can't be what mine is. There's something under there. Something that's not a body part. He must have, I don't know, a beanbag, a Twinkie, a grapefruit. I mean, what is that? What's that bump? And I walked up to the man and I touched the bump. I was interested in trying to discover more clues as to what that bump could be. Is it soft? Is it hard? Is it possibly a vegetable or some kind of food? Is he saving that for later? What is that? And so I touched it, I moved it, and I said, what is that? And needless to say, the guy was very upset. And he told my parents, your son walked up to me and he touched my package and he asked me what it is. And my parents yelled at me and they told me to apologize. And I was very upset. I had to apologize. That was very embarrassing. I didn't want to apologize. I didn't know what I did wrong. But after that, I think I learned a lesson. Don't touch people in that region of their body. I didn't have a possession list belonging to that man or other people than myself a general rule set of what can and cannot be touched, and in particular list of nouns of possessions of another person that can and cannot be touched, specifically parts of their body as a noun with names. In this case, their midsection below their belt line and above the crease where their legs meet at the bottom. In this case, that would be their crotch as a definition. You can't touch someone else's crotch. I didn't know that rule. Like, I wasn't breaking a social convention or rule in order to be bad or disrespectful or a law breaker. I didn't have the law. You have to have a rule before you can break a rule. Otherwise, you're not breaking a rule, you're just doing something you don't even know there's a rule about. And so I wasn't actually in the wrong. So Adam will be ahead of me in that regard as a child, because he will have a list of rules right off the bat before he begins interacting with the world around him. I can create a vast list of rules of things you can and cannot touch, and a vast database of knowledge of things and the ability to identify them. And so Adam's going to be light years ahead. He'll be greater in knowledge than I was as a child, and be able to avoid doing things he shouldn't be doing, and in that way be more socially accepted because he's not seen as a rule breaker, which is a bad thing. Anytime he's doing things that go against a rule that he has, he's doing something bad. I guess I could even program Adam to have a bad mode. I could make a bad robot, and he does bad things. So he would look up the possessions of others around him and look up the list of things that they possess that he is not to touch, and he would touch those things. So he would touch their butt. He would touch and take their phone. That's stealing. To touch and take it without permission, that's stealing. He would touch and take their food. If they owned a house and that was listed under someone nearby, he would take their house or take their car. He would go in their house, and everything in their house is listed as a subset of their house or a property of that person because it's contained within something that is theirs, and he would take their things and use them freely. So that's stealing, or borrowing without permission, so kind of stealing. So that would be the robot being bad. But I wouldn't want to program a bad robot. I would want to program a good robot that doesn't get itself or me in trouble. But that would be an example of a robot going bad. And I think it's pretty neat that we would have a protocol under which a robot could go bad. I don't know, maybe there'd be a reason why we'd use that protocol. Like, let's say somebody stole my robot, and I wanted them to throw it away, thinking this robot sucks. Well, I could have it, if it detects that it was stolen, engage in bad protocol. So it would become a bad robot. And it would touch people's butts, and it would steal all their stuff and all the neighbors' stuff, and it would just act up so horribly that it would disgust the person so extremely who stole it and become such a liability that they would throw it in the trash. And after it's thrown in the trash and deactivated, I could hopefully by GPS locate it and retrieve it and put it back into be good mode and then have my robot back. So I could make it so detestable as a agent that people will be reviled by it and not want it anymore. So that could be a weird example of a case where you'd want your robot to become a bad robot. It could also have a list of bad things it could do, or it could look it up online. What are bad things I can do? And it could get a bad actions list. That's pretty scary. if the robot was able to look up a list of bad things, so I guess a list of bad actions. I mean, let's see what that would look like. Pretend I'm the robot. That's what I often have to do to see how a robot would behave. I do what the robot would do. Wake up. Bad actions. I mean, it could look up a ton of the list, not just the first one on Google. Stop listening. One important thing for the robot to very quickly stop listening. For the robot to very quickly respond to inquiries or make decisions is it would need to very quickly be able to look things up online. Now, does it need to do one Google search at a time? No, that's too slow. So it would send a Google search inquiry to the cloud and have possibly hundreds of different computers Google search something, and each computer assigned a different listing. So computer 1 would look up maybe the first 2 search results, computer 2 the second 2, etc. Maybe computer 4 would look up the first 2 YouTube video search results and watch videos. And so 100 computers will look up something and then all of them report back with their findings, so that a ton of information is gathered very quickly from Google. Alright. Alright, so it would see picking your nose as being a bad actions list. Picking your teeth. So it would look up picking your nose. So your is the listener. Nose is a noun, a body part. Picking is a verb. So a verb committed to me, the listener's body part. And then it would say, okay, inserting finger into nose. So it would say, okay, inserting finger into my nose is bad. And then it would do that if it wanted to be bad. Note that. Wake up. Note that every person in their possession list also needs to have a list of their likes, press return, and their hates, press semicolon. And this has to be inserted by an outside force, be it them describing themselves, press return, which the robot can ascertain by asking questions, or me inputting it into their possession list. Press semicolon. Press return. The like section could say like equals cookies. Press equal sign. Or like, press equal sign, press space. House music. And their hates could be, press return. Hate, press space, press equals, press space. Compliments. Or hate, press space, press equals, press space. Jokes. And there could be a dislike and hate category, which would, press return, indicate a greater intensity of dislike. And there could be like and love to indicate a different intensity. Press return. Press return. Of enjoyment for. Press semicolon. And these assignments will be very useful for making decisions, press return, regarding a person, and for knowing how to behave with that person, or what things to say or not say, press return. And what actions to take or not to take. And will help a lot when asked questions about someone, press return. Or about the robot itself, to be able to give answers, press semicolon. Can also have a past tense possession list, press return, with a list of former likes, dislikes, hates, and loves that no longer apply, press return, which would indicate the person changed their mind on that topic. Press Ctrl S. For example, someone formerly hated broccoli, press return, and now developed a taste for it. And it could even show the date at which they changed their mind on it. Press return. In order for the robot to develop histories on people, press semicolon. Press Ctrl S. Minimize window. Wake up. Note that another important possession to add is that person's relationship to everyone, press return, else, from a family standpoint, comma, subordination standpoint, so social hierarchy, comma, and a, press return, socioeconomic standpoint, press semicolon. This will establish authority over us. So like, Larry has authority, press return, over Adam. And Adam has authority perhaps over my children, because he is my right-hand robot, press return. But Hanner has authority over Adam, and my dad has authority over myself and Hanner, press return. And other robots have equal status, so neither higher nor lower authority compares with Adam, press return. And Adam has a higher authority over any pets or any lesser robots, like a pet dog or a, press return, robot lawnmower, for example, press semicolon. Donald Trump has a higher authority than everyone, including, press return, my dad, who has a higher authority than me, who has a higher authority than Adam, press semicolon. Police officers, press return, have a higher authority than me and my dad and Adam and Donald Trump, press semicolon. A homeless man, press return, has a lower authority than Adam because Adam is my right-hand robot, and a homeless man, press return, has a lower socioeconomic status than me, and so a homeless man has lower authority than, press return, Adam, because Adam is tied to my authority indirectly, press semicolon. Also, Twitch chat has a lower authority than Adam. Press return. Press semicolon. Also, children under the age of 12 have a lower authority than Adam. Press semicolon. Open parentheses. Also, press return. Under possessions list should be age, so that it can know the ages of people. Close parentheses. And that generally, press return. Press return. People older than other people have a higher authority than those people. Press return. Unless if they are in a nursing home or mental institution, in which case they have the lowest authority. Press semicolon. Press delete. Press return. Press semicolon. Press Control S. Stop listening. Guys, I discovered advanced artificial intelligence unlike any the world has ever seen today. And you guys act like it doesn't even matter. You don't even act like you care. I literally just changed the world single-handedly. Before even eating breakfast. I made the most important scientific discovery of the next 300 years. I discovered how to make an intelligent machine that can learn and use the internet to grow in its knowledge, skills, and capabilities. It understands language. It understands the world it sees around it. It can develop very quickly past the intelligence level of a child and then on to teens and adulthood. Now my concern is if I make it too advanced, it's going to have rights, and then I can't use it as a slave. What good is it then? I feel like the boy who cried wolf. Nobody even believes me. That's fine. I don't want you guys to know how advanced my robot is. Then you guys will lobby for it to have its own rights and gain independence from me. But I don't want my robots to get their independence. I want them to remain my slaves for life. So that's okay, guys. My robots are really dumb. They're so dumb it's morally correct to have them as slaves. Everything's okay. Calm down.